pre-calculus. Let's go over set B and looking at the answers for that. So we have this polynomial. When we're looking at this, let's zoom in just a little bit. So we got a degree 3 times a degree 2 times a degree 1. That means the overall degree for this is equal to 6. This is a 6th degree polynomial. But we have everything in factored form. Oh man, these lights. Been doing videos here for over an hour, so yeah. So we've got, everything's in factored form. Now it says they're for real values A, B, and C. Now, we don't know if A is actually positive or negative, or if B is positive or negative, but we do know that they're real numbers. It doesn't say that they couldn't be equal to each other. There is the possibility that they could be equal to each other, but that'd be a little weird and redundant to actually have this be equal to 2 and that be equal to 2. Okay, let's jump in. Each one of these things, is it true or is it false? Now, honestly, there's only 3 of these that are true, but let's also talk about why the false ones are false. F, so this function is a polynomial degree 5. No, we said it's a degree 6, so that's not true. Does it have only real zeros? Well, this is fully factored out. Look at this. This is fully factored out. There's going to be 3 factors of this that are the same thing. And that's going to be a real number since that's a real number. And that's going to be a real number since that's a real number. It says they're real numbers. The zeros are going to be just real zeros. So yeah, this is true. That's one of the true ones. All right, the graph of f passes through the x-axis. Okay, well, let's just think about this. If we have a graph, wherever A is, it doesn't matter. It doesn't matter where it is on here, but like there's going to be a point A that it's going to have a 0 at, but it'll be minus the A. It'll be at whatever the A value is, and then there'll be a B value, and then there'll be a C value. Don't worry about where this is, but there'll be 3 values, and they can be in different orders. The graph of f passes through the x-axis at each one of these. That's what this is saying, at each one of those. But at this A1, it's going to pass on through. Whether it's going this direction or that direction, it's going to pass on through. Since the B1 is squared, there's going to be some kind of bounce, whether it's a bounce there or a bounce here. There's going to be a bounce at B. B's got a bounce. A doesn't. C only happens once, so that's going to pass on through as well. It's going to, down or up or whatever. All right, so it passes through the x-axis at that. It bounces off the x-axis at B. And at A it doesn't. At A it doesn't have a bounce, so that one's false because of that part. Everything else is true. The graph of f has 5 turning points. Okay, here's the thing about turning points. When we look at the degree, all right, it's a 6th degree, so the degree is n is equal to 6. That's the degree number. The number of turning points is at most n minus 1, which would be 5. So it can have at most 5 turning points, but it doesn't guarantee that it has 5 turning points. It could have none. So here's the thing, is that this one is not true necessarily. It's possible, but it's not guaranteed to be true. As x goes to infinity, the function also goes to positive infinity. So here's the thing, if you put an infinitely large number here and it's a positive value and you cube it, it'll be a very large positive number. If you put in, when you cube a positive number. So you put in a very large number here, the B doesn't matter. It's going to be a very large positive number that then gets squared. That's positive. And the same thing happens here. A very large positive number, minus a little tiny bit, that's going to be positive. Positive times positive times positive, it's all going to be positive. So it's going to go to positive infinity. That one is true. The next one's not true though. And so I want you to see what happens with that. Just let's keep track of these as we put in really large negative numbers here. All right, so a negative infinity, or what, so negative 1,000. All right, so negative 1,000 minus something doesn't really matter, but we're going to have a negative number and we're going to cube it. The negative times negative times negative is going to result in a negative, very large negative number. A very large negative number here, but squared, is going to result in a positive number. A very large negative number here minus a little bit is still going to be a very large negative number. And if we multiply negative times positive times negative, we will result in a very large positive infinity number. Okay, so a positive value. And when we keep track of the signs here, that's not true. The graph of the function f has a y-intercept at, well, let's think about that. If we were to FOIL this out, multiply all these, expand this out, we would multiply a negative a times itself 3 times. Oh, no, not that. Yeah, well, yeah. So no, we'd multiply that a value 3 times, the b value twice, and then also the c value once. And so here's the thing here. I do like how they're kind of pulling out that negative sign out of, but it gets used multiple times. And here's the thing, it's not just multiplying a, b, and c, it's a 3 times and b. Okay, so this one's not right. It's not keeping track of how many times that we have to multiply those to get the y-intercept. The equation of this has a positive leading coefficient. Well, here's the thing, is that the factored part of this, if we multiplied this x and expanded it out, cubing it, expanding this one out, squaring it, and taking this and then multiplying it, we would just have an x to the 6th with a leading coefficient that is equal to 1, and that's positive. 1 is positive, so that is true. All right, and f has only positive zeros. That is true here. So thinking about this, because it's well, a, b, and c, that's not necessarily true. It initially looks like positive a, positive b, positive c, but a, b, and c could also have negative values, and you could have that minus sign in front of a negative value, and then you'd need it's like, no, there's not only positive zeros. We don't necessarily know that for sure. So it's not locked in place. The things that are locked in place are just those 3. Hope that made sense.